Okay, so we're going to look at scalars versus vectors. Really, I just want you all to understand and be able understand the difference between these and to be able to recognize them. So let's go through our notes. All right, you have your handout, and I'm going to tell you what to put in it. All right, so scalars. So first we want to define it. Y'all see that little box where it says definition? All right, so a scalar quantity has only a magnitude. And you're like, what is magnitude, right? Is that a word that you hear often? Probably not. But when we're looking at numbers, magnitude is just that value. For example, 727 years. Magnitude is the value, the number 727. There is no direction given with scalar quantities. Okay. Um, this tape measure right here is a tool that is used for measuring scalar quantities, this balance, and also this thermometer. And then here are some examples of scalar quantities. This is all stuff that you should be used to, right? 1.5 kilograms, 2.3 centimeters, 29 degrees Celsius, 100 calories. Right? They give us magnitude, but we do not have direction. Are there any questions about that? All right. And then what we're going to do in just a second, we'll look at vectors and how vector quantities differ from scalar quantities. All right, guys, ready? All right, so vectors. A vector is a quantity that has both a magnitude and direction. So if you look at this example here, and you have an arrow on your paper, you have one that you're going to put the definition in, and then you have another one. Excuse me. So if we look at this example here, we have 25 kilometers north, 10 degrees west, right? We have magnitude, right? km, the kilometers, that's the unit. And then what's in brackets, that's the direction. All right, and that's what makes this different from a scalar quantity, just the fact that we have direction. And direction is always written in square brackets. Okay, what we use to get direction is a compass, and so that's why there's an image of a compass, and you have that image on your handout. And then this thing right here is the spring scale. And how does this measure a vector quantity? Well, it measures force in a certain direction, and typically that's like down. But because there is direction, it is a vector quantity. And you can write that on your handout. You see where the spring scale is located? You can put that on your handout. The spring scale is on the left side of your paper. All right, are there any questions about the difference between scalar quantities or vector quantities? Any questions about that? Because what we're going to do next is you guys are going to identify which of the following are vectors. In order to be classified as a vector, what do you have? What do you have to have? And you got to have magnitude and direction. You got to have both of those. So basically, excuse me, I have to give you a number, and you have to have direction with it. All right, are you ready? Okay. So let's ID some vectors. All right, so what's the first vector? All right, so the 19.6 north to the left. There you go. What's the second one? All right, so 45 kilometers per hour north, 20 degrees west. Do we have another vector? All right, so 9.8 meters per second squared down. Do we have, okay, 3.01 kilometers east. And there's, all right, so right here, 1.7 meters per second south, and I didn't highlight that one. So 1.7 meters per second south. I got to highlight that because it's going to bother me. All right, any questions about this? I know, I'm about to highlight it now. And there we go. And look at that. And there we go. 1.7 meters per second south. Boom. There we have it. All right. Are there any questions? Can you tell the difference if I had some type of assessment, which I don't have? Can you tell the difference between a scalar quantity and a vector? All right. Good job.